The topic of this video is solving exponential growth and decay problems. Let's look at a problem. The half-life of radium is 1,690 years. If 90 grams are present now, how much will be present in 700 years? Okay, we notice that we have not been given an equation for this problem, so we are going to try and use the short way, making a table and looking for a pattern to see if that helps us solve the problem. If not, at least it gives us what we need to solve the problem the long way. Okay, so whenever creating a table, you're always going to put time in the column on the left. In this case, we're measuring time in years. We can see that was stated in the problem. And we're always going to put amount in the column on the right. And in this case, we're measuring the amount in grams. The problem says if 90 grams are present now. Now is time 0, so I get 0 and 90. And it says the half-life is 1,690 years. That means when 1,690 years pass, the amount is cut in half. 90 divided by 2 is 45. The question is, how much will be present in 700 years? Now, if I were to continue this pattern, adding 1,690 over and over again on the left, and dividing by 2 over and over again on the right, would I eventually get the number 700 years to appear in my table? The answer is no. It's somewhere in between 0 and 1690, so creating additional rows for the table is not going to help us. Therefore, we are not able to solve this problem the short way. But by creating the table, it's given us the information we need to solve the problem the long way. So with each row of the table, we are adding 1,690. That's the value of A, the adder. And with each value of the table, we are cutting it in half. That's dividing by 2. The value of the divider is 2. Our formula for K is that it equals the natural log of 1 over D, all divided by A. So for this problem, K will be equal to the natural log of 1/2, all divided by 1,690. Okay, so short way did not work. Let's go the long way. We need to use the long way equation, which says A of t is equal to A naught e to the kt power. Remember, we're going to leave k in our problem until the very end, and once we have an answer in terms of k, we will use this fraction at that time. Do not put this in place of k until the very end of the problem. Okay, so let's start filling in parts of this equation that we know. First, A naught. A naught is the amount, A, when the time is 0, which we can see from our table is 90. When the time is 0, the amount is 90. So this is going to be 90 e to the kt, and this is going to be A of t. The question said, how much will be present in 700 years? Well, that means that we know the time. 700 years is going to go right here, and we're looking for the amount. How much is present? So the answer to the question will be A of 700 equals 90 e to the k times 700. Okay, this is the point where you're going to pick up your calculator and you're going to put all of this in your calculator. Just remember that you need to replace k with this fraction. Now, depending on the kind of calculator you have, you may have the ability to put the whole thing in your calculator all at once. Or you may find that you need to get a value of k here as a decimal and then enter this into your calculator. If you use that second approach, make sure you do not round. You need to keep every decimal value that your calculator shows you for k so that when you put it into here, you do not lose any value according to rounding. All right, so what I'm going to do is I'm going to use my TI-30XS Multiview calculator, and I'm going to enter this entire thing as a single expression. So here we go. First thing I'm going to do is enter the 90. Then I need e raised to a power, so I'm going to do the second button followed by the ln button. My power needs to be k times 700. Now k happens to be this fraction, so I'm going to hit the fraction button, n over d. I'm going to enter the top, which is the natural log of 1/2, ln. It gives me parenthesis, so all I have to do is 1 divide 2, close parenthesis. I'll use the d-pad to get down to the denominator, where I can put 1,690. I'll use the d-pad to get alongside the fraction. Then I can put my parentheses times 700. Closing parentheses and hitting enter, I get the value 67.53914,042. There are no rounding instructions stated in this problem, so I'm just going to make something up here and say that the amount is approximately 67.539 grams. All right, this is our final answer, but before we call it done, let's verify that this answer makes sense to us. We know that we started with 90 grams, and that if 1,690 years go by, that amount will be cut in half, which will take it to 45. So, how much time is passing? 700. That's not quite as much. Going from 0 to 700 is less than going from 0 to 1690. So what that means is that the answer that we should get, our final answer for this problem, since 700 is between here and here, the amount we get should be between here and here, between 45 and 90. And indeed, the answer we get, 67.539 approximately, is between 45 and 90, which gives me confidence that we have the correct answer. We've now completed this problem.